Ladies and gentlemen, good evening. Tonight we're going to talk about the Java stream and the reduce method. There are a lot of people that still doesn't use all of the magic that we actually get from the stream, from the Java streams. So this video is about that, and we are specifically going to use the reduce method to add up a lot of numbers. So first of all, let us create a test. So I have a test right here. This is my Spring Boot Cucumber project that I have right here. We have some aliens. Let us just look at the aliens. And here, these aliens, they have some weight. And our problem tonight is that we need to check that if these chubby aliens are too chubby, so they cannot be on board of our spaceship, or maybe the aliens are slim enough and it's okay to actually bring them, or maybe we have to maybe we have to bring a bit fewer aliens if they weigh too much. We can have to transport them over multiple flights instead, of course. So that's our situation. So we have this entity right here, and since we are playing with entities and we have the H2 set up and all that, then I think we should actually create these into the database. So let us start with creating some aliens. I was thinking that we need 4 or 5 aliens. So what could we do? We can actually use the post construct method in Spring Boot, and that's what I'm going to do. So I'm going to say alien default data like this, and then I can say that this is configuration. And here that I can say I can also just create it as a component. It does not. Yeah, let us create it as a component, not component scan, as a component. So this is a component. Then we say after this has been created, then do public void create default aliens. So now we're going to create some default aliens like this. We're going to add some required Axe constructor, private final alien repository, because we need to be able to save these aliens right here. So here we have the aliens, and let us try to save them. So we can, of course, we could have just created a list of them and save them in one batch. We can also choose them to save them one at a time. So we can say like this, save, and then we can say new alien, and ID should be null. The type could be, should it be a Martian? And the name could be Mike, and the weight could be 115 kilograms. The height could be 120 centimeters. Yes, the unit is not there, but that's just how it is. Okay, so instead of using save right here, we could actually use save all, as I just said, so let us actually do that. It's easier to use save one by one, but just to do something different, then I'm going to do this. So I'm going to create a list of aliens like this. It is more efficient actually to batch up your saves like this, but it's easier to debug if you save one alien at a time. So let us just, okay, now we create a lot of aliens. So we have one named Susan, Paulina, Lillian, Isabella, then we have Brian, Mike, Paul, and Adam. So now we have a lot of aliens right here. We can maybe change the weight a bit. So maybe the Susan alien weighs 70, the Paulina weighs 60, and Lillian maybe weighs 90. And this is not real people or anything like that. So if I know someone where the name actually matches, then this is not you. I'm just making up some aliens right here. Mike, that is correct. And then we have Adam. So now we have a lot of aliens, and their weight is put right there. So actually, so that is their weight, and right now I'm using an integer. Let us do that to begin with. So to begin with, we're using an integer. Later on, after when we're done with the integer, then we want to change this to a big decimal, or we want to create another weight that is called weight, the big decimal or something like that, because I want you to see the strength of the reduce method. If you use an integer, then you could actually use the sum method instead, and we don't want to be able to use that, right? We want to use big decimals because then we still have the precision. If you're using floats and doubles, then you will lose precision, and if you can watch my other video about precision and data and which data types you use in Java. The short answer is, and spoiler alert, use big decimal for everything if there's a decimal, and if you want precise numbers, and if you want actually your numbers to be able to be multiplied without any errors. Okay, so they're all Martians right now. It doesn't matter what type they are. So yeah, so that is really good. Now let us create a test. Create test. And yes, I am just going to create a test on this method right here. It does not matter what we name our test. So this is a Spring Boot test. I need the context this time, but I don't need the web stuff. So I'll say web environment none, just to save some time on the startup of our tests. So on here then we say, then we actually just say alien repository, and then we wire in with AutoWire. This is the only place that you can use AutoWire. If you're using AutoWire someplace else in your application and then in your test, then you should go back and read some more Spring Boot documentation, or you should watch some more of my videos, of course. That's also one option. Sorry. So now we have the alien repository, find all. We just want all of our aliens, and then we want the weights of all of these aliens to see if we can actually transport all of these aliens in one go in our spaceship. And our spaceship has some kind of limit. Limits could be like 1,500 kilograms. That could be the limit. And then you say, of course you already start like this. You will say all.for. And then you have some kind of int right here, summed weight, or something like that. And you know what? This code would actually work. So if you do that, it's okay. It's not very cool, and you would lose some status from your developer colleagues, but you'll still get the work done, and your boss will be happy. The business would also be happy. So everybody would actually be happy, except for you'll feel a bit dirty, so you maybe want to take a shower after doing code like this. But now we will just do this for now, just for fun. And then we can do some system out, print line like this. And in here we can then say summed weight equal to. Of course, we could also use string formats. String.format. Let us use the string format actually. So then we have percentage s right here, and then we have the limit percentage s right there. So now we say that we want the summed weight. That's this one right here, and then we want the limit. As soon as you have more than two strings to concatenate, definitely use the string formats, and you can also set decimals, and you can also what does it complain about now? Redundant call. Okay, that was actually a bit yeah. It's good we have IntelliJ, because I can actually, instead of using print, then I could actually use printf instead. This means that is the formatted output instead. So thank you very much, IntelliJ, for helping me out with that one. Okay, so and this n right here, that is the integer. Let us run this test and see what actually happens. So summed weight 652 kilograms. The limit is 1500. That's fine. Now we can actually yeah. So that's actually fine, and no problem with this solution right here. You'll still be fine. You will not lose your job or anything. But your colleagues will laugh at you behind your back, just so you know. So let us try with another approach instead. We will try to use the stream. And if you are older than If you're so old that you actually started with Java 4 or something like that, then it's kind of okay. So because this came in Java 8, the streams, so if you're very, very old and you're just about to be retired, then this approach is totally fine. No one will laugh behind your back. They will actually just say, they will say yes. So just because this is a good old Mike, right? He is still fresh in his mind, so we will just leave him alone. But if you are a developer that wants to follow up on new technology and new versions, then you definitely need to use the stream instead. Okay, so we say create default, and then we say with, okay, wait some stream. So now we are using streams. Then we say all.stream. And what can we do now? What can we do now to get this on? We know that we need to map it, right? So we need to map it to. Here we have the alien, so we have to map it to the alien. And if you don't know how to use the method references, because of course that is the nice way, and we will also use the method references right here, then just start with getting the weight right here, and then IntelliJ will actually help you. Then IntelliJ will say, hey, your colleagues will laugh at you if you do this code right here. So replace with the method reference instead. And that is what actually happened there. So now we have converted our alien into the weight, and now we need to reduce it. Then look, here we have the reducer. Awesome. So here we have and then we need to give it something called an identity. That is a start value. And then we need to say what it should actually do. So here we have the function, and here then we will say. Here then we will say the binary operator. Then we know that it's an integer. So then we will say add the integer, right? And it's actually an integer, so we can actually use a method reference. So we can actually say integer, and then we can say. Then we can say sum. We can actually use sum right here. Integer. Let us see what this leaves us actually. So here we have the reduced value. Let's see what happens now. So instead of print line, again, you can format your output instead. Then we can say reduced value, and then percentage s, and then we say reduced value like this. So let us see what it actually says now. What do we get? We get 652. Okay. So that is quite good. It was the same result. But Mike, what do we do when it is a big integer, when it's not like one of the primitives, you'll probably ask. And you can also, instead of the reducer, then we just duplicate this. Actually, instead of reduce right here, we don't want to use reduce yet. Because they can actually use that is actually the collect. And then we have here, where do we have it? Here, summing int. Let's try this. So, let me just check something. I want to sum them, the numbers, and we have a. It should actually just be that. Okay, so let us remove this one right here. So I'll say map, but instead of map, then I'll say map to int. And then we will say alien value. and then we will say sum, like this, yes. So this is one way to get the sum also. So then here we'll just write sum. Actually, I think I spoiled the point actually. So by using that reduce, I wanted to use sum first to show you that you can also use sum. And here we have 652 again, so the value is still good. And if you have an integer, of course, that's fine. Be my guest, add the numbers like that. But if you have, let's say, a big decimal instead. So instead of get weight, now I'll add a new field. We'll say weight big decimal. So now this is a precise weight. So let's just say this is a precise, and here we'll say this is a big decimal, like this. And then we have to go back to our default data. And then we say here we have the 70, then we say big decimal. Actually, the best way actually is to say new big decimal. And then we can actually just say a string if that's what we want to. So here we say 70.432 like this, 34. And then we say yes. And let us create some more precise big decimals, precise big decimals, precise big... Oh, it is the wrong place. Here it was correct. Here we have it here, we have it there. So now we are adding a precise weight. And let us have something that actually is almost the same as the integer number. And I know it's not roundable to the integer value, but it's very close by. So it's just to have some numbers right here. And I want to get another value actually. So now we have big decimals instead. Yeah, and is that much more difficult? No, it's not. Thank you very much for the question. It is not more difficult. Because here now we can, if we want the precise, now we want the precise weight instead, and we don't want it we want it as a big decimal instead, right? We want that result instead, and this also means that you can actually reduce. Of course, you can use your custom functions to reduce your streams, and it is not just usable just for summing up, but you can also like. I don't know. You can do a lot of weird stuff. It's only your own imagination. Of course, you can also concatenate all of if you have some string names, but there's a better way to do that with the collectors. Yeah. So always when you have a list, use the streams because it's magic, right? And it's much easier and it's much faster to code. So here we have a stream. Then we say map, and here we get the alien. And again, we could just say alien dot get weight precise. So now we have the big decimals, and here we say you would use. And here we need to say what is the initial value. The initial value is the big decimal dot 0. And now it's a big decimal, so we need to say that we need to use a method on the big decimal. And here we can say add. Okay, so that means that we could also have multiplied the numbers actually, if we wanted to do that. And we say precise. Let us run this one right here. And of course now I now I had an error another place in my code because I created a service right here where I can create aliens, but now let us see right here. So now this is the value. Okay, cool. And of course, we should assert something because so big decimal. And if you don't know, then assert J is actually a part of of Spring Boot by default. So you should definitely use that. It's much easier to read. Of course, no one will fire you for using JUnit, and no one will blame you. But again, your colleagues will laugh behind your back. No, they will not do that. Testing it, there's so many ways to test, and there are so many opinions about it. But assert J, it's just more readable. So if you say with assert J, you have to say assert that something. So that means that we have to say assert that, and then we can use whatever it is that we are using to assert, and that is the precise number. In this situation, we want this to be equal to, is equal to, and then we can have another big decimal. Here we will say new big decimal, like this, and then we will actually paste in this number right here. So let us see what actually happens. First, let us try to make it red first, just to see that it goes red. Test-driven development. First you write a test that is red, then you create the code, and then it will be green. And then you can put test-driven development on your CV. Yes, now it's green. That's all for tonight. Thank you very much for watching, and thank you very much for all of your comments. Thank you very much, and hope to see you again soon. Have a great evening. Bye-bye.